The mathematical symbol of today is modulo, written as M-O-D, mod. This is the modulo operator, which I explain here as a binary operator. Which means we have a number x on the left hand side and a number n on the right hand side. And this whole operation here gives us a number back. Indeed, often x and n are chosen as positive integers, but the whole thing also works for positive real numbers. Now, the whole idea of this operation is that you get the remainder after you divide x by n. For example, if you consider 5 mod 3, you immediately see 3 only fits 1 times into 5. So what remains, what you can't divide, is 2. In other words, 5 is not a multiple of 3, we have to subtract 2 to get 1. Therefore, the next example is simpler. If you have 6 mod 3, you see this fits well, we get out 0 as the remainder. So you see, if we divide 6 by 3, we get out exactly 2. But we are not interested in the 2, we are only interested in the remainder, which is 0 in this case. Okay, then with the next example, maybe let's leave the integers, and now we consider 7.1 mod 3. Also here, we find that the 3 fits 2 times into the number on the left hand side. Hence, the remainder term is exactly 1.1. So I hope you now know how this works. I like thinking of subtracting 3 so many times until something less than 3 remains. And the thing that remains is exactly our result. So maybe I should also explain this with an example. So let's consider 9.7 mod 2.1. So first, let's subtract 2.1 here. So we get 7.6. So let's do it again, and then we get 5.5. Of course, we do it again, and then we get 3.4. And then in the last step, we finally get 1.3. Which is of course less than 2.1. Hence, this is our result here. So this is how you can think of this, but the important thing is always remember it's the remainder term we want here. Hence, here for the definition, we could simply say this is a number R. And this number lies in the interval 0 to n, where n is not included. However, of course, the remainder term could be 0. Moreover, now we also know how we get this number R, because we can write x as a sum. Namely, it's n times an integer we can call q plus the remainder term r. So you see, for our positive numbers x and n, this is exactly the procedure we explained before. Okay, now for the end of the video, I want to show you how the modulo operator is included in Python. Indeed, this is simple. Instead of mod, we use the percentage sign. So you see, this is exactly what the modulo operator should do. And of course, it also works for our decimal numbers as we had it before. However, as you can see, what can occur are some rounding errors. Okay, and with this, I hope I see you next time. Bye!